Alright. So we're doing coordinate geometry again. What do we have? We've got okay, first things first. Points. We understand that we've got point A, which is xy, and we can have point B, which for argument's sake we started labeling this as x1, y2, and then x1, y1, x2, y2. I could have labeled this little a, and then B, and then C and D, for example. It's up to me, but they just found it easier to teach if they just wrote this as x1, y1, x2, y2. Okay, and then you learned that obviously a coordinate needs to be written in terms of x first and then y second. That's just the way the alphabet is. X before y, and that's your x-axis, and that's your y-axis. These are your positive numbers, these are your positive y numbers, these are your negative x numbers, these are your negative y numbers. Okay? Alright, I'm not going to go through the whole plotting stage. I think that's something that you should understand already. Let's start looking at the formula. So we have the midpoint formula, the very first and easiest one, midpoint. As this one suggests, it's a point. Okay, so if it's a point, you must have a coordinate like that. You must have an x value, you must have a y value. So your midpoint should be written in this form, and then that's when you learned the midpoint formula is this. Okay, where it's obviously really easy to now note, all it's trying to say is add the two x values up, divided by 2. Add the two y values up, divided by 2. That's it. So if I gave you a point, and I'll make it tricky, minus 6, minus 7, b is minus 2 and 5, all you got to do is add the two values up for the x's. So it's a good habit to get used to labeling them. There you go. Alright, so you're going to go add x1 and x2, so minus 6 plus minus 2, all over 2. That's what x equals to, and then y equals to minus 7 plus 5 over 2. Minus 6 plus minus 2 is minus 8, over 2 is minus 4. Y is minus 2 over 2, which is minus 1. And that's your midpoint. Easy stuff, right? Okay. Let's go with gradient now. Gradient is represented usually by the letter m, so if you see that, as you saw through y equals to mx plus b, that equation is trying to tell us m is the gradient, but for now we've just got the gradient m, and that equals to rise over run. Okay. The only downside to this is you must check your slope. So if it's sloped like this, it's positive to the right, if you see that, and then if it's sloped to the left, okay, it's going to the left, can you see that? It's negative left. Okay, so a question for this could be a minus 2 minus 6, b is minus 4, 5. Well, because we don't have the rise, we got to go in, sketch it first, right? So, minus 2, minus 6, somewhere down here. That's minus 2, minus 6. That's A. B, minus 4, 5. B. It's a good habit to get used to stating them as well.
Yeah.
Okay, so now you want the rise over the run. That's it, which gives you this slope. All right, but check the slope. The slope, is it negative or positive right now? So you already know that you should have negative slope, right? And then you got rise over run. Negative. Now what's my rise? Well, I know from here to there, that's 5. My y value, okay? Don't mix it up. That's the only error I see with students. My rise here is 6. So my overall rise is 11. Over my run. Well, I've got 2, minus 2 here to minus 4. Obviously, that's a run of 2, right? Or you can just check your distances out. That whole thing is 4. That little part there is 2. So that must mean that little inside there is 4 takeaway 2, which is 2. You get what I did there? 4 takeaway 2 gives you 2 inside here. That's it. That's your gradient. Minus 11 over 2. Any questions? Okay. Now we're going to look at distance formula. But I don't think you really require distance formula yet. Okay? But I'll write it just for your formula sheet, but it shouldn't be something you should test. But anyways. If you remember Pythagoras' theorem, then you should remember this. Because Pythagoras' theorem comes from this. See, there's the squared. There's the squared. There's a plus in between. So you already know that you should have something squared plus something squared. That something is just x2 take away x1 and y2 minus y1. That's it. Why is it minus? Because you want the distance a. Before, you had a triangle. A was the actual value. Oh, sorry, a would be here, for example, if we're looking at x's. And b would be there, right? But the point is you had a distance of b. Now, that distance is in midair. What is that distance? And that's what we just saw with rise over run. The way you calculate it, you've got to calculate all that, take away that part there. In this case, if it was like this, you would go, okay, it's that part there plus that part there, for example, and you get all of this. It just depends, right? But that's it. That's exactly what you're doing. So, but the takeaway would do it all the time. It will take into account the negative, so you don't need to plus ever. Right? The takeaway will take that into account. That's the whole point of the takeaway. That's it. So you should be able to memorize, and the reason why it's square root because they've already square rooted. So a lot of advanced students just understand it's just this, and that's okay. Whoops. And it doesn't matter if you remember x1, x2, as long as you understand the x's are together. A lot of students just memorize that. So it's actually c squared, there it is, c squared, equals a squared plus b squared. Yeah. A lot of students I saw got scared with the square root. So I decided to teach this. I'm like, hey, if you see this better, fair enough. As long as you remember the last line, you got a square root. Yeah. And that's where the square root comes in. So I'll give you a question. We'll go minus 6, 5b, minus 2, minus 3. Again, label is a good technique to get used to. x1, y1, x2, y2. I recommend as soon as you walk into your exam, the first thing you write is probably as much as you can remember from all 3 formulas. And that way you don't have to keep writing the formulas out for every question. Anyways, distance formula. So d, we'll do d squared, equals to this, or whichever one, doesn't make a difference. I always do the second one. So this, in brackets, minus 2, minus, because of the formula, sorry. Alright, because of the formula, minus, and then minus 6. All squared, plus b squared, right? That's Pythagoras' theorem. So then minus 3, take away 5 squared. Minus 2 plus 6 is positive 4. 4 squared is 16. Plus minus 3 minus another 5, you have minus 8. But then you're all squaring it. Do not put minus 8 in your calculator. Do not put this in your calculator. Your calculator will give you minus 64. Right? You guys should know by now. Brackets. So it'll give you positive 64. That's it. So careful with that. Where was I? So minus 8 all squared is positive 64. 64 plus 16 is 80. And therefore d equals to root 80. That's it. Alright, now you learned what's called the gradient intercept form. Gradient intercept form. So it must have a gradient, it must have an intercept. That's the whole point of it, right? The form of it looks like this. That's my gradient. So whatever's in front of my x is my gradient, and whatever. If it's negative, then you have to say that negative as well. And b is my y-intercept. Okay, it's not the x-intercept, it's the y-intercept. Now, I like to just understand where this comes from again so that you don't have to memorize. If you know what an intercept means, intercept, it cuts through, right? It intercepts there, that's the y-intercept, and the x-intercept would be here. So I'll label that as x-intercept, and I'll label that as y-intercept. Alright, what do we know about the y-intercept then? Well, we don't know anything about the y value here at all. All we know is about the x value, in fact. That sounds weird. But Sam, it cuts through the y. We know that's a y there. Well, we don't know exactly how far up or down it's gone. We don't even know if this y is positive. For all we know, it could have been negative. I just drew this. Right? But I know something. If it lies on this line, if it definitely lies on this line, I know, I'm going to rub that out, Control Z. Alright? I know that my x is always going to be 0 on that line. Because I'm not going to go anywhere to the left nor to the right. So I don't know nothing about my y, but I know for y-intercept, it must occur when x equals to 0. And similarly, for my x-intercept, it must occur, again, let's look, I don't know where my x-intercept is. I don't know the value of it. I can work it out. And that's through making y equals to 0 this time. So I know that y is 0 at my x-intercept. So wherever it cuts my x-axis, well, at that point, I'm not going up or down. So my y is 0. Alright, and if you want to see how y-intercept is always b, so how this is always the y-intercept, you can check it. Look, sub in x is 0. When x is 0, what's m times 0? 0. 0 plus b is b. So therefore the y-intercept is b. For x-intercept, that's a little bit trickier, obviously, because you're making y is 0 now. So you've got to make this one become 0. Right? So when you let that is 0, there it is. 0 equals to mx plus b. For x-intercept, you're solving for x. That's it, you just got to solve. And it's not hard. You take away b, divide by m. Alright, you take away b, and then you want to make x the subject, so minus b over m. That would be your x-intercept, apparently. Cool? But you're not really caring about that yet. You're only in year 8. But why not? It's not that hard. It's just equations. Okay? You just make y become 0 and you solve for x. Here, you let x be 0, you solve for y. Any questions? Okay, that's called the gradient set form. So I'll give you a couple of questions here. Let's go. Y is equal to 2x plus 5. What's my gradient? What should be my gradient? It's in this form. Y equals to mx plus b. What was the gradient again? Exactly, that's a gradient. And that's the y-intercept, okay? So what's my gradient? 2. What's my y-intercept? 5. What's my gradient? What's my gradient? Yeah, so which one? What should it be here? No. Whatever's in front of my x.
Okay, 5. Negative 5.
Yeah, or negative 5. What's my y-intercept? It's my constant, the one that has nothing attached to it. Right? That's minus 2. That's my b, that's my m. Cool? So I switched it around. And you should understand that. You should have said that first go, I reckon. Y equals mx. You need to have the m in front with the x plus b. B is on its own, it's a constant. What's m?
M is negative 2.
That's it. It's whatever's attached in front of it. And y-intercept is? That's it. Y equals to 6 over 7. Okay. I think that's it. Let's pause this. Okay. So general form now. So we had the let me write it like this. we had gradient intercept form. And now we've got the general form. Okay, so gradient intercept form, we saw it must be y equals to mx plus b. The key point is y is the subject. That's the key point. That's it. As long as y is the subject, we don't care how else, anything else. So if you have something like this, which we did before, right? You want to make it into gradient intercept form. How? By making y the subject, get rid of this x. It comes down to this side. So y is equal to positive 5, take away x. Or you could have written it as minus x plus 5. Same thing. Cool? That's called the gradient intercept form. So if you have things like this, your key point is, I want to make y the subject, so everything else on the other side, y on its own. This one, I feel like sometimes a little bit easier. This is the form for it. ax plus by plus c equals to 0. Okay. Now, the key thing with this is a cannot be negative nor a fraction. Cannot be. So if you have minus 2x, you have to get rid of the minus. How? Just change all the other signs. Okay, because if it's negative, positive, positive, just make it positive, negative, negative. That's allowed because you're changing everything, right? Even the 0, but 0 stays a 0, right? So it's not, that's why that's the whole point. Okay, and it's a fraction. Again, you got to get rid of the fraction. So how do I get rid of a denominator? You times it by whatever that fraction is, by everything. All right, we'll have a look at some, but that's it. So the key thing with this is everything on the one side. That's it. So everything on one side. That's it. So an example would be, imagine it is this one. Y equals 5 minus x. It told me to write it in general form. That means everything to the one side. So all of this must go to this side. So I'm going to take away the 5 and I'm going to plus the x. Or you could just take away the y. But then it'll still be a minus x. The y, can it be negative?
Yes.
Yeah, the y can be negative. Alright, we're going to bring in this side. So it's going to be x plus y minus 5 equals 0. And you're done. That is in general form. For example, imagine I did take it. I'll show you it now. So it's going to be 0 is equal to 5 minus x minus y. Again, we usually like to write, x up front, and then the y, and then the constant. That's just, again, convention. So rearrange it, you'll get something like this. That's fine. It is kind of in general form, but because you're not allowed to have that there, right? Because you're not allowed to have that negative there, you're allowed to go times everything by negative 1, or divide everything by negative 1. So therefore, you're not really changing the actual size of it or the magnitude. You're just changing the sign. So negative turns into positive. Negative turns into positive. Positive turns into negative. You can look at it through timesing negative 1. Something like that. Okay? Alright. Well, let's do another one. Let's go with, imagine it was y is equal to 3 over 2x plus 7. I would like to write it in general form. Well, okay, I know I can just take this to this side. So I get 3 over 2x plus, I'll write it quicker, minus y, and then plus 7 equals 0. So I just took the y, and that's it. That's what I get. Okay, I'm happy with that. I'm almost there. It's in general form. However, I can have a fraction here. So I times everything by? I haven't changed nothing. Still allowed. Cool. That's it. Let's write this in y equals mx plus b form. Yeah, so gradient intercept form. Nice being able to change. Y equals mx plus b. So, what would you like to do?
So we're going
There's no wrong answer. Hope you know that, right? There's just sometimes a little bit more efficient answers.
yeah.
Go.
Alright, so you cancel out the 0. But it's here and then you 0. And then you rewire everything else out.
Yeah, okay, you don't cancel it out. You're moving it. So it's 0 take away 4y, which is minus 4y.
Yeah.
So you're going to get 2x minus 6 equals to minus 4y. Look, you got y on its own. That's good.
Then you divide everything by negative 4.
So you divide everything by negative 4, so that should be just this one by negative 4?
All of it.
All of it, like that?
Yeah.
Cool. So I get y is equal to minus half x plus 3 over 2. Yep. Cool. Can I have fractions for these y equals mx plus b forms?
I think so. Yeah.
You can. I didn't say anything about it, so you can.
Yeah.
That's it.